Hi guys, welcome to our example video. So in this video we're going to be covering all of the examples and take all of the concepts we learned in our previous intro video to algebraic equations. We're going to take it, we're going to apply it, and we're going to see what is the proper methodology to use, what is the approach to follow every time we're doing and solving an algebraic equation. Okay, so we'll start with number one. I have 5 examples on the board, so I'll start with example number 1. Okay, so remember the first thing I said was, remember what is your end goal. So in this case, my end goal is what is x equal to. So everything I'm going to do from this point to this point is trying to get my variable on my left hand side and all my constants on my right hand side. Okay, so remember I said, how are we going to get to my end goal? I'm going to make use of inverse operations. Remember the inverse of addition was subtraction. But with an equation, remember the whole basis of an equation is that the one side is equal to the other side. So if ever you're making an adjustment to the left side, you have to do the same to the right hand side. So we minus the 6 aside. What do I have? I have a 9 this side, so I'm going to do the same thing to the right hand side. Now, I've subtracted the 6 on the left hand side, I've subtracted the 6 on the right hand side. This equation is staying equal. Okay? This is obviously going to cancel each other out. I'm now left with my end goal, which is just x. 9 minus 6 gives me 3. And that is my answer using inverse operations. Okay, moving on to example number 2. Sorry. Again, first thing I'm asking myself is, what is my end goal? My end goal is x is equal to. I'm trying to find out what is my x value. Okay, so again, everything I'm doing from this point to this point, I have to get my variables on the left hand side, constants on the right hand side. How is negative 2 bound to x? It's multiplication. Okay, so this is negative 2 multiplied by x. What is the inverse of multiplication? It is division. So I'm going to divide this entire term by the negative 2. But remember what I do to the one side, I have to do to the other side to keep this equation equal. So that's going to cancel out because if you divide anything by itself, it just gives you 1. Okay. Therefore, I am left with my end goal, which is just x, or that invisible 1x. Okay. 14 divided by negative 2, or positive divided by negative gives me a negative. 14 divided by 2 gives me 7. And that is my answer for number 2. Okay. Moving on to example number 3. It's something similar, but again, we're focusing on the same approach, we're using the same methodology. What is my end goal? I'm asking myself. How am I going to get there? Inverse operations. How is this? Remember, I have to get x alone on this side and all my constants on the right hand side. How is x and 5 bound to each other? By division. This is x divided by 5. What is the inverse of division? It is multiplication. So I'm going to multiply by 5 to cancel out the 5 on the left hand side. Okay. So, but remember what you do to the left hand side, you have to do to the right hand side, keep my equation equal. So this is technically going to cancel out because 5 divided by 5 just gives me, again, that invisible 1. I'm therefore left with my end goal, negative 6 multiplied by 5. So negative times a positive gives me a negative answer. 6 times 5 gives me 30. And so that's my answer. Right, second last example. I have x plus 3, and this is all over 2, okay, and it is equal to 6. So remember in the previous video I said we're going to do it in opposite order of BEDMAS. So this is going to be first addition and subtraction, then multiplication and division, then exponents if applicable, which is not in this case, then brackets lastly. Okay, so in this example I can then see I first, you would say, okay, I first have to add and subtract. But because this 2 has to be divided, or x and positive 3 must be divided by the 2, I can't simply take the 3 over. Okay, I have to first, like this whole thing is bound together by this division or divided by 2. Look at it as if it's a bracket around it. Okay, so I can't just separate this 2. I have to first get rid of the 2. So this is, you can say, is an exception to this. Okay, so I first have to get rid of the 2. How is this 2 bound to the top? By division. So I use the inverse operation, which is multiplication. What you do to the one side, you have to do to the other side. This 2 then cancels out. Now I'm left with x plus 3 on my left hand side, and I'm left with 12 on my right hand side. 6 times positive 2 just gives me 12. Okay, now obviously all I have to do is, what is my end goal? How do I get from x plus 3 is equal to 12 to simply x? I have to use inverse operations. So that is positive, my inverse is negative. what you do to the one side, you have to do to the other side. 12 minus 3 just gives me 9, and that is my answer. Okay, so just watch out for a situation like this when I have two terms on the top, and that is either multiplied by or divided by one single number. I'll first get rid of that number before breaking up the two on the top. Okay, then in my last equation example, okay, so here we can see distributive law coming in a little bit. If you watch our previous video with distributive law, you'll notice that this is something I have to split out first. Okay, so we're going to follow exactly the same approach. We're going to say, what is my end goal? My end goal is to find what x is. So everything I do from here to here is getting x alone on the side, getting all my constants on this side, and using inverse operations. Okay, so the first thing I'll do is multiply out wherever I need to. So I'll use, here I can see I need to apply distributive law. Okay. So I'm going to leave my 5x plus 4 on the side for now. I'm not going to do anything to it, but on this side I'm going to have to multiply out. If you're struggling with this, just pop out a distributive law video and it will make a little bit more sense. Okay, so I'm going to multiply out. This will then give me 3x. 3 times 3 gives me 9. Okay, that was the only thing I had to multiply out. That was affected by distributive law. The 1 is separate. It's on the other side, so I'm leaving it there. Okay, so I want to get all of my x's on my left hand side, all of my constants on my right hand side. So I'm trying to bring this 3 over. So I'll do that first. Okay, so I have to bring this over. So I'm going to group my 5x and my negative 3x together because they are like terms. What do I have left here? I have my positive 4. Right, what do I have left on this side? I have a 9 and I have a 1. Now we're almost there, almost all my variables on the side. I just have to get rid of my 4. Again, that's a positive 4. To get rid of it, I use its inverse operation. What you do to the one side, I have to do to the other side. So at the end, I'm left with 5x minus 3x is equal to, that is now cancelled out, 9 plus 1 minus 4, so that gives me 10, minus 4 gives me 6. Okay, I'm almost there. So I'm left with 5x. Remember, these are like terms. Okay, 5 minus 3 gives me 2x, and that is still equal to my 6. How do I get to my end goal? I'm almost there. That is bound by multiplication. So I have to divide on either side. There, I'm finally at the end. X is therefore equal to 6 divided by 2, which simply gives me 3. Okay, I hope you enjoyed this video, guys. If you're struggling with any of the concepts we covered previously, please pop out to that videos, and we'll see you next time.